Hello everyone, this is Dharamveer sir here. So today we are going to start chapter 12 of grade 12 maths, which is linear programming problem. Okay, so in this video we will learn about how to solve a linear programming problem using graphs. So let's start. So first let me tell you the meaning of an optimization problem. So any problem which seeks to maximize or minimize a function is called an optimization problem. So whenever we have to find the maximum or minimum of a function, it is called an optimization problem. So an optimization problem may involve maximization of profit, production, diet problem, cost problem, or minimization of all these factors. Okay, either maximization or minimization, or in some cases both. Okay, so such problems are called optimization problems. So a linear programming problem deals with the optimization, that is maximization or minimization of a linear function of two variables x and y known as objective functions. Objective function subject to the condition that the variables are non-negative, that is x and y should be always positive, and in some cases maybe 0, and satisfy a set of linear inequalities called linear constants. Okay, so a linear programming problem is a special type of optimization problem. So in a linear programming problem, we have a function which we need to maximize or minimize. That function contains two variables x or y, two non-negative variables x and y, and the function is put under some conditions which that function have to satisfy, called as linear constants. Clear? So let me tell you the meaning of objective function. So linear function z equals to ax plus by, where a and b are constants, which has to be maximized or minimized, is called a linear objective function. So the function which we need to maximize or minimize is called the objective function. Now decision variables. So in the objective function z equals to ax plus by, x and y are called the decision variables, the variables on which the function depends. Constraints. So the linear inequalities are called restrictions on the variables of an LPP, that is linear programming problem, are called constraints. The condition x greater or equal to 0, y greater or equal to 0 are called non-negative constants. Constant means the inequalities which restricts the variables. Feasible reason. So the common reason determined by all the constants, including non-negative constants x greater or equal to 0, y greater or equal to 0, of an LPP is called the feasible reason for the problem. In grade 11th we have learned linear equalities, where we used to find the solution reason of the given inequalities. So that solution reason will be our feasible reason. Clear? So pause and note down these definitions. Next we have feasible solution. So points within and on the boundary of the feasible reason for an LPP represent feasible solution. So we got that common reason that called feasible solution, and the points on the boundary or inside that reason are called feasible solution for the LPP. Infeasible solution means any point outside of the feasible region. So all those points which are outside of the feasible region are called the infeasible solutions. Optimal, that is feasible solution. Any point in the feasible region that gives the optimal value, maximum or minimum, of the objective function is called an optimal solution. So the point on which we get the maximum or minimum value is called the optimal solution. So keeping all these points in mind, let's start exercise 12.1. The question 1 is maximize z equals to 3x plus 4y subject to the constraints x plus y less or equal to 4, x greater or equal to 0, y greater or equal to 0. So first we have to plot these three inequalities: x plus y less or equal to 4, x greater or equal to 0, and y greater or equal to 0. So we have just plotted the graph as shown in the figure. X plus y less or equal to 4 this line. We know that x greater or equal to 0 means what? Y-axis, and y greater or equal to 0 is the x-axis. So you can see the common region, the shaded part. This one is our common region called the feasible region. Okay, so plot the graphs as you learned in grade 11th. So the corner points of the feasible region are the origin 0, 0, point A 4, 0, and point B 0, 4. So we have to find the values of z at these points. So at O, that is 0, 0, the value of z, that is 3x plus 4y, is 0. At A, that is 4, 0, the value of z is 12. And at B, that is 0, 4, the value of z is 16. So the maximum value of z is at B 0, 4. 0, 4. Clear? So pause and note down the solution. Next we have question 2. Minimize z equals to minus 3x plus 4y subject to x plus 2y less or equal to 8, 3x plus 2y less or equal to 12, x greater or equal to 0, y greater or equal to 0. So plotting the graphs of the given inequalities, we obtain this graph as we used to do in grade 11th. So we have the two lines, x plus 2y less or equal to 8, 3x plus 2y less or equal to 12, x greater or equal to 0, that is y-axis, and y greater or equal to 0 as axis. And we get the common solution region at the shaded portion. So in the figure you can see we have 1, 2, 3, 4 corner points. O, that is 0, 0, A, that is 4, 0, B, that is 2, 3, and C, that is 0, 4. Now we have to find the value of z at these points. So the value of z, that is minus 3x plus 4y, at O 0, 0 is 0, at A 4, 0 is minus 12, at B 2, 3 is 6, and at C 0, 4 is 16. So the minimum value of z is at the point A, which is 4, 0, and the minimum value is minus 12. Clear? So pause and note down the solution. Moving to question 3. Maximize z equals to 5x plus 3y subject to 3x plus 5y less or equal to 15, 5x plus 2y less or equal to 10, x greater or equal to 0, y greater or equal to 0. So plotting the graph for the given inequalities, the feasible region obtained by plotting the constants 3x plus 5y less or equal to 15, 5x plus 2y less or equal to 10, x greater or equal to 0, y greater or equal to 0, we get this graph. And the shaded portion is our feasible region. So again we are getting four corner points O, A, B, C. O, A, B, C, as you can see in the graph. So the corner points of the feasible region are O, that is 0, 0 origin, A, that is 2, 0, P, that is 0, 3, and C, that is 20 upon 19 and 45 upon 19. Now we have to find the value of Z, 5x plus 3y at these corner points. So at O, origin, the value of Z is 0. At A, 2, 0, the value of Z is 10. At B, 0, 3, the value of Z is 9. At C, 20 upon 19, 45 upon 19, the value of Z is 235 upon 19. So it's clear that the maximum value of Z is at C, that is 20 upon 19, 45 upon 19, and the maximum value is 235 upon 19. Clear? So pause and note down the solution. Moving to question 5. Maximize z equals to 3x plus 2y subject to x plus 2y less or equal to 10, 3x plus y less or equal to 15, x and y greater or equal to 0. So plotting the graph for the given inequalities, we get the graph as shown in the figure. Now the feasible region obtained by the constants x plus 2y less or equal to 10, 3x plus y less or equal to 15, x, y greater or equal to 0 is the shaded portion as shown in the figure. So again we are getting four corner points O, A, B and C. So the corner points are O, that is 0, 0, A, that is 5, 0, B that is 4 3, C that is 0 5. So the value, we have to find the value of Z at these points. So finding the value of Z, 3x plus 2y at A 5 0 is 15, B that is 4 3, it is 18, and C at 0 5 the value of Z is 0. So the maximum value of Z is 18 at the point 4 3. Clear? So pause and note down the solution. Moving to question 8. Minimize and maximize. So we have to find both maximum and minimum. Minimize and maximize Z equals to x plus 2y, subject to x plus 2y greater or equal to 0, greater or equal to 100, 2x minus y less or equal to 0, 2x plus y less or equal to 200, x and y greater or equal to 0. So plotting the graph for the inequalities, we get the graph as shown in the figure. Now the feasible reason, determine the constants x plus 2y greater or equal to 100, 2x minus y less or equal to 0, 2x plus y less or equal to 200, x greater or equal to 0, y equal to 0, y greater or equal to 0 is the shaded portion as shown in the figure. So here we have the corner points A, B, C, D. Okay. So finding the value of the function z, x plus 2y at the corner point A 0 50, B 20 40, C 50 100, and D 0 200. We get the value of A, that is 0 50. The value of z at A, that is 0 50, is 100. The value of B, the value of z at B 20 40 is again 100. The value of z at C 50 100 is 250, and the value of z at D 0 200 is 400. So we have two minimums and the maximum is 400. So the maximum value of z is 400 at 0 200, and the minimum value of z is 100 at point A and point B, that is point 0 and 50 and 20 and 40. Clear? So pause and note down the solution. With this we end the exercise. So solve the remaining sums and don't forget to solve the examples. Thank you and all the best.